Computing the area of a sector. I have good news for you. Computing the area of a sector is done exactly the same way as you compute the arc length or the length of an arc. Exactly the same. The only difference is that instead of using the circumference formula, you use the area formula for the circle. So suppose you have a circle and you want to compute the area of a slice of this pie. So we want to compute the area of that. Well, this is done exactly the same way as arc length. So first thing is you have to start by computing the area of the whole thing. So remember that when we did arc length, we wanted to find the length of the little piece, this part, this arc. We first started by computing the length of the whole thing. Okay, so now for the area of a sector is the same thing. We compute the area of the whole thing, so you have to know how to compute the area of a circle, pi r squared, and then you're going to take that and you're going to multiply by the fraction of the circle that corresponds to the angle. And reminder, it is the angle over the total. The total is 2 pi if it's in irradians, and the total is 360 if it is in degrees. And that's it. Now, in the specific case in which the angle is measured in radians, in that specific case, then the procedure gives us the following. Pi r squared times theta, and I say we're measuring in radians, over 2 pi, and you can simplify this by canceling the pi, and you will get r squared theta over 2, which is the formula in the textbook. Now, once again, this formula does not work unless you're talking about radians. So you have then two ways of doing this, either the way I just explained or using the formula. But if the angle is not in radians, then you cannot use the formula. What you have to do in that case is switch from degrees to radians and then use the formula. Which way you use, it doesn't matter. It's whatever you like better. All right. Example 11. Find the area of a sector of a circle of radius 7 inches with a central angle of 70. Okay, so you can imagine the circle. So that's 70 degrees and the radius is 7. We have to find the area of the sector. Okay, so the area is going to be, first we find the area of the whole thing, which is pi r squared. And the r is 7 inches. So pi times 7 squared times the fraction corresponding to the angle. The fraction is the angle, which is 70. Okay, I should have written 70 there. Over, this is in degrees, so over 360. So I'm going to put here 70. Okay, now that's a 0 instead of a theta. Okay, now let's simplify this. We can cancel the 0. There. And we can put this in the calculator. I'm gonna leave it in terms of pi, so I'm just gonna multiply the numbers out. So 7 squared times 7 is 343 pi over 36. Okay, and that's it. You cannot simplify that anymore. And this is inches. Okay, and that's it. If they ask you to round, then you enter this in the calculator and you round. So let's see, what would that be? So 343 times pi divided by 36. That would be about 29.93 using 2 decimals. And this is not inches, by the way, it's actually inches squared because it's area. Square inches. All right? And that's all. So it is very simple. Okay, you can try to figure this one out if you like. So it says the following. There's a lawn sprinkler that throws water over a distance of 20 feet. If it rotates back and forth through an angle of 50 degrees, what is the area of the region that it waters? So you could pause the video and try this one. Okay, so you can draw a little picture if you want. Not needed, but good. So the radius is 20 feet, right? And then the angle is 50 degrees. So what is the area of that? Okay, the area is, find the area of the whole circle first, so pi r squared. So the radius is 20, so 20 squared, times, and then you multiply by the fraction that corresponds to the angle. This one happens to be in terms of degrees as well, so it would be over 360. If you want in terms of radians, divide by 2 pi instead. Okay, now let's simplify this. You can cancel those zeros, and then we will have 20. You can put it in a calculator. 20 squared is 400, and 400 times 5 is 2,000. 400 times 5. Yeah, 2,000 pi over 36. Now we can simplify this a little bit more because we could divide by 4, top and bottom. So 2,000 divided by 4 is 500. So this is going to be 500 pi over 9. And this is square feet. And that's the answer. Now let's put in the calculator to see what that is rounded to 2 decimal places. So this would be approximately 500 times pi divided by 9. It is 174.53 174.53 square feet. All right, that's it. Now, the very last thing we will mention for this section in the book, for this lesson, is linear and angular speed. Okay, so recall from probably high school or physics that that if you have an object that is moving along a straight line, such as a car in a straight, not in a curve, but like a straight line, then the average speed of the car or of the object is just the distance that it travels divided by the time it takes it to travel that distance. So if the car travels 60 miles per hour, no, sorry, 60 miles in 2 hours, that would be the average speed would be 30 miles per hour. So you take the distance and divide it by the time it takes to travel that distance. So using variables, it could be written like this. Speed equals distance d divided by t. Distance divided by time. So for an object that is moving not in a straight line, but along a circle, you could define the angular speed and the linear speed. Okay, now you have a circle and you have an object moving not in a straight line, but along a circle. The angular speed is defined pretty much exactly the same way as this. If you look at the formulas, they're almost the same. Okay, you have the same form. So the angular speed would be the angle, which is like, the distance traveled, but in terms of the angle. Could be in terms of degrees or in terms of radians in general. But for this particular formula, it has to be in terms of degrees. Radians. Okay, I put it right there, so let me highlight it. There's another formula for degrees, but it's different. you would have to change the radians to degrees. And then use this formula, and you would get the corresponding formula for degrees. All right, so it is just the distance traveled in terms of radians divided by the time. Again, the formulas are almost the same. Now, the linear speed would be, well, for the linear speed, then you take the distance traveled, which is the length of the arc, and you divide it by t. But if you remember that the formula for arc length, when you have it in terms of radians, the arc length is really the same as r theta over t. And now this part right here is the same as w or omega. So that means the angular velocity times the radius gives you the velocity. So the angular speed times the radius gives you the linear speed. So that's the relationship between the linear speed and the angular speed. The angular speed is the radians over the time, and then the linear speed is the angular speed times the radius. Okay, let's use these formulas to do this problem. This is not hard. So it says Captain Jack just hopped on the edge of a merry-go-round. What are his linear and angular speeds if the diameter of the merry-go-round is 10 feet and it takes 4 seconds for it to make a complete revolution? All right, we want to find the angular speed. The angular speed is just the angle divided by t. Now it takes him 4 seconds to do the whole revolution. So that means in 4 seconds, he completes 2 pi. He completes the entire circle. He goes around. So that is it. Let's simplify this. This simplifies to actually pi over 2. And this is, what are the units on the top? Feet. And the units on the bottom? Seconds. That's it. That's all. That's the angular speed. And what is the linear speed? That's easy. The linear speed is you take the angular speed and multiply by the radius. So pi over 2 times, what is it? The radius is 10 feet. Times 10. So this is 5 pi. Okay, that is all. This is, excuse me, the units here are not feet. This is angular velocity. This is radians. Radians per second. The units here are feet per second. My bad. Okay, now that's it. Reminder, when computing angular speed, the angle needs to be in radians. If it's in degrees, you need to change it to radians first.